So when we build a reaction, we're going to talk about, given two starting compounds, we're going to be able to predict our outcomes or our products. Okay, we are going to predict the reaction. Okay, so if we're given two starting compounds, we're going to be able to predict what they would form when they go through a chemical reaction. Okay, and we are going to focus mostly on double displacement reactions because they're the simplest for us to predict the outcomes. Okay, so let's review a little bit of what a double displacement reaction looks like. Okay, a double displacement reaction starts with two complex molecules, right? They're not simple molecules. It's got more than one type of atom, okay? And when they combine in a chemical reaction, what makes the switch? Do you remember? In a double displacement reaction? Yeah, Rachel, what do you think?
They're like the cations and the anions that they were paired with before, what they become.
Perfect. Okay, so we talked about the cation and the anion from each of these compounds. They just switch places. Okay, so the cation here and the anion here would form a new compound, AD, and the next compound we would form would be between what? B and C. Good. And would it be written like this? B, C? Good. The cation has to come first. And since C was the cation from the second compound, it would be written like that, CB. Okay, that's what a double displacement reaction looks like. Does it make any difference to us what order we write these two compounds in? Which one comes first? CB or AD? Does it matter which one comes first? No, it makes absolutely no difference. Same with our starting compounds. Does it matter if AB goes first or CD goes first? No, it makes absolutely no difference. The thing that does matter is which compounds are combining with which. Okay, the order in which you write them makes no difference. Okay, so let's go ahead and try one here. We're going to have to get really, really toned up with our naming skills again. Okay, I know it's been a while since we've done compound naming and building compounds, but we have to be good at that again. Okay, because if we build our compound incorrectly, will our chemical reaction balance? No, right? If we're missing a sulfur within our compound, that means we're going to be missing a sulfur overall. It could be disastrous. Okay, so we got to make sure that we're really confident with our building chemical compounds from our word forms. Okay? So this says sodium nitrate reacts with calcium fluoride to create. Okay, what do we think? So this is where it comes to us building the reaction. Okay, so let's go ahead and start with just the reaction, and then we'll do the actual question part, the stoichiometry part that goes with it. Okay, sodium nitrate, that's what we're going to start with. Okay, these problems take a little bit of time to get through. So the first thing we want to do is build sodium nitrate. Okay, sodium is Na, and what's its charge? +1. Nitrate is good, NO3 -1. Okay, so if we combine those, what's the ratio between these two compounds? Or these two elements, or whatever you want to call them? Yeah, it's a 1-to-1. So when they combine, it's just NaNO3. We don't need any extra subscripts. Okay. Okay, calcium fluoride. Calcium is what charge? +2, good. Fluoride is what charge? -1. So how many fluorides do we need to cancel out that calcium? Good. CaF2. Okay, so we would get rid of the charges, cross them down, it would work the same way. Okay, so that's our first part. We did what we were given. Now we need to predict the products. Okay, so when we predict the products, what would we assume that sodium will be bonding with? Fluoride. And what would we assume nitrate would be bonding with? Calcium. Okay, here's the tricky part. The subscripts that go with these in the first problem, like this F2, doesn't mean that that subscript's going to carry to the products, right? We have to look at the individual ratio or the charges between those two new, that new combination. Okay, so let's look at first, we'll go sodium fluoride first. Okay, so a combination now between sodium and fluoride. Sodium's +1, fluoride's -1. So our new compound would just be NaF, right? Even though it was F2 here, does not mean that it's going to be F2 here. Okay, does that part make sense? A lot of you will want to carry that subscript through. That is not the case. Start all the way over when you build those new products.
Wait, so you just decide which one bonds by putting the negative with the new positive?
The negatives go with the other positives. The positives go with the other negatives. Yep. And it'll always make this inside out kind of V. So if you need to draw that, you can too. Okay? Okay, so that means that our other combination is going to be between what two compounds here? Or what two elements or molecules? Calcium and nitrate. So calcium is a +2. Nitrate is NO3 -1. Okay, so how many nitrates do we need to cancel out that calcium? 2. Ca parentheses NO3 parentheses 2. Okay. Now we need to balance this equation. Okay, so we have all of our compounds written correctly. We need to balance it. We have 2 nitrates on this side, right? So we need 2 nitrates over here. We have 2 fluorines here, so we need 2 on this side. Okay, does that look about right? Since nitrate itself didn't split up, right? You don't have to break it down into nitrogen and oxygen. You are welcome to do so. But since nitrate didn't split up, you can just count nitrates on this side and nitrates on the other. Okay, that's totally up to you if you want to do that. Okay, all the other elements pretty much go by themselves. So we see 2 sodiums here, 2 sodiums here, 2 nitrates, 2 nitrates, 1 calcium, 1 calcium, 2 fluorine, and 2 fluorine. Okay. Questions up to that point? Okay. We've built and we've balanced our reaction. Now we're going to answer our question here. If I start with 83.2 grams of sodium nitrate, how many grams of calcium nitrate will be produced? Okay, so we're going to do a gram to gram stoichiometry problem here. Okay, so when we start doing our stoichiometry, what do we always start with? What we know. 83.2 grams of sodium nitrate, NaNO3. Okay, so I want to go grams of sodium nitrate to moles of sodium nitrate. Okay, and what goes here? What? The molar mass right there. Moles always gets the 1. Okay, so you guys can calculate molar mass on your own. I'll ask for it here in a second. It's 85. Okay, I'm sorry. 85. Okay, so we're done with grams of sodium nitrate. We're left in moles of sodium nitrate, which is not what we want. We want to go 2 moles of calcium nitrate. Okay, and what's our mole ratio here? Top to bottom, what's our mole ratio? 1 to 2, very good. Now we would say 1 mole of calcium nitrate is to so many grams of calcium nitrate. Yeah, you might want to put the polyatomic ions out on a piece of paper in front of you. That way you can reference them if you need to. Okay, so lithium is a +1. Phosphate is PO4 -3. Okay, so if we think about it in terms of making it a neutral compound, okay, I need 3 lithiums to balance out that phosphate. Or if you think about crossing them down, it would leave me like this, Li3PO4. Okay, does that make sense? Which way makes more sense to you, thinking about it making it neutral or crossing them down? Okay, all right, then that's fine. Lose the charges and then crisscross. Okay? This is double displacement. Yeah, I'm only going to give you double displacement reactions. Yeah, good question.
Wait, so how do you decide which one goes first?
It makes no difference which one you list here first.
No, I don't mean which one you list, but like,
Oh, why didn't phosphate go before aluminum?
Yeah.
The cation has to go first.
okay.
So positive and then negative.
Okay.
Yeah, good question. Okay, people that did it on their own, did we get to that balanced reaction? Exactly, yeah, there's just one of these, and then when we balance it here, it's because aluminum is a +3 and phosphate is -3. Yeah, anytime we leave it off, when you're talking about balancing the total equation, yeah, since we only need, 3 lithiums and we need 3 nitrates, we just put 3 there, and then all the other ones just. Is that what you're talking about, or the compound? Okay. That's right. When it asks for the mass, what should we be taking that all the way to? Grams. Good. Good.
Colin, do you have any of your old quizzes you could just get out from Polygon?
Right here?
Yeah.
And what's the other one? 199?
199. Yeah.
213, okay. Did you only use, I don't know. Yeah, alright.
Oh, it's 3 nitrates, no wonder.
Yeah. Okay, did we get about 543 grams?